Okay, bald is sick, but you can only really pull off being bald if you have hair, like on your face, which you can do. But I'd still rather be ginger. All right, you will be given an exam this week. You will have until next Friday to complete the exam. We will not be having class next Wednesday because I do like to take one class off, and I won't be here anyways next Wednesday. I'm going to be at LES, so you will have that day off. Today we're going to cover a review problem, and this is kind of review, kind of an application of material, because I do think it's important to understand why it is that we're studying these aspects of machine design. All right, so the nice thing about doing an example problem is that one example problem can literally cover all of machine design that we've covered so far, because we just started with materials, then we moved to stress analysis, then we moved to static failure, then we moved to fatigue failure, and all of those, it's just a progression in a line of things that you have to do. Here's the problem. Oh yeah, and then we have a 12-inch rod that we are going to be designing. This thing is going to be experiencing a 20 kip load. Okay. Now our load is going to be oscillating between 0 and 20 kips. Our goal is, can we design this rod to be able to handle this load? Okay? So, what do we do first? Now, we know we're going to need a couple of things in order to figure out any kind of stresses, right? What do we need? We need to know the type of load. So let's go ahead, because I kind of gave you that, I will draw out a free body diagram. And we'll say here is our 0 to 20 kip load F, right in the middle, located at 6 inches, and then this is going to be a 12-inch long beam. Okay? What do we do now? There's a couple things we need to do before we can calculate the stress. We can come up with shear and bending diagrams right away. All right, so here, V, because it's right in the middle, I'm just going to cheat. I know that the force is going to be distributed halfway between both of them. If you do your sum of your moments, you can find that out, but I'm not going to, because this is a high-level class. We don't have to go back through that. Shear moment diagram is going to look like this, where this distance is going to be anywhere from 0 to 20 kips, and this is just going to be 0 to 10 kips, and 0 to negative 10 kips. Okay, and that's what the shear force diagram looks like. Bending force diagram will just look like this. Right here, M is going to be at 0 to 120 kip inches, where it's at its maximum. Okay, now what do we do? Barnabas is looking at his notes. You're going to find out we have a real big problem here. Does anybody know what problem we have? We don't know the cross-section. Okay? Now, keywords in this is going to be that we're designing this. So, in order for us to figure this out, there's going to be an infinite number of solutions. This is one of those problems, unfortunately, and as an instructor, they get really difficult to be able to handle. Because now that we have an infinite number of solutions, there's a whole bunch of things we don't know. And as part of this class, I do not know what the solution is going to look like at this point. We're just coming up with a solution. So we need to come up with a cross-section. What makes sense for a cross-section? We could do round. When you think of rod, you think, yeah, round. Could be an I-beam. Could be a square tube. There's so many things here that we just don't know. We got to pick a shape. So let's do some voting.
And for applications, you'd kind of figure out what shape you need based on what your problem is too, right?
Some of it is based on your problem. Some of it is like, I want it to be the cheapest. I want it to be the lightest weight. And so as you do the analysis, you may do two different shapes just to try to figure out which one's going to be lightest. But then again, you might also do two different shapes and then figure out what both of them are going to cost. So I don't want to do two different shapes because, I mean, we're not doing that good of a job in this problem. So we got to vote on three shapes. We got round, which I'm going to go ahead and change that to be a hollow tube. Hollow tube, I-beam, square cross section. All right, who wants hollow tube? We got 4. Who wants I-beam? You're gonna vote twice? I counted your votes twice. So who wants square tube? Wow. Okay, you voting twice screwed everything up.
Three-way tie.
It was literally a three-way tie.
I want just I-beam.
Okay, so now you're just I-beam, so that means this is now 3, 4, 4. All right, now we got to vote again. Everybody who voted for the round tube, the 3 of you, you are the tiebreaker. Okay, so who are the 3 people who voted for the round tube? Okay. You 3 are the only ones voting now. I-beam? Chandler's the one. Square tube.